This is a practice test for Algebra 2, and the test will be on section 7.1 and 7.2. It's not exactly the same format. What you see here is pretty basic. I don't have any extra lines to show you where you're going to put information, but there are some on the test that kind of lead you to give you your answer. So the test is actually probably a little easier than this, since there will be a lot of blanks that you'll need to fill in so you don't forget anything. So section 7.1 and 7.2, we have show all work, decide whether or not the listed function represents exponential growth or decay, then give the percent of growth or decay, sample answer 42% growth, then identify the y-intercept. So to give you a chance to do these, go ahead and pause the video and do problems number 1, 2, and 3, and then I will work through them. Taking a look at these three problems, what we want to do is identify the base. And the base for number 1 is 1.7. There is no negative exponent up above, so I don't have to think that this is some kind of trick. It's already been simplified. That number is bigger than 1, so this is going to be exponential growth. The second part says give the percent of growth or decay, and we remember that the growth formula says 1 plus r. So I'm looking for r, which means I don't need the 1. And that would be 0.7, which would be 70%, because it came out to be 1.7. And then it says identify the y-intercept, and the y-intercept for all of these will be 0a. And this is y equals a times b to the x, so this problem will be 0.25 or 25/100ths. So going back over this, it is growth. The percentage of growth is 70%, and the y-intercept is going to be 0 and 0.25. Number 2, same thinking here, y equals a times b to the x, but this time the base is a fraction between 0 and 1 because that's 56/100ths. So this is going to be decay. Now with that one, we have to think it was 1 minus something that gave us that 0.56. So thinking backwards, or maybe even using a little algebra, you could do it this way. And then you could go ahead and subtract 1 from both sides. So 0.56 basically minus $1. Negative r would give you a negative 0.44, thinking in terms of hundredths here. So dividing both sides by a negative 1 would get us 0.44. So that would be 44% decay. Identify the y-intercept. Again, it's going to be 0a, and a in this case is 4. So going back over number 2, this would be decay with a decay rate of 44%, and we have 0.4 as the y-intercept. Number 3, as I write my a times b to the x down, I realize that's a negative exponent up there, and that negative exponent is to trick me. That is what it's for. So what I have to do is remember that that's the reciprocal of whatever is in the parentheses, because the parentheses are the closest thing to the left of the power. So now when I look at this, I can see that I definitely have a base that's a fraction between 0 and 1. So this is decay with a 1/8. And then what I want to think is, okay, how do I get the 1/8? Well, it's decay, so 1 minus r had to equal 1/8. Again, you can think of this in terms of just solving it algebraically and saying, all right, well, I'd have to subtract 1 from both sides. So 1/8 minus 1, and you can certainly do that on your calculator, and don't forget you can use the fraction button, so let me talk you through that. You would do parentheses 1 divided by 8, parentheses, minus 1, and you'll get the answer negative 0.875, and if you hit math number 1, you'll get a negative 7/8. Or you could just use common denominators and say, all right, 1 would be, we'd be subtracting a negative 8/8, which would be negative 7/8. And then, of course, divide both sides by a negative 1 will give you r equals 7/8. So when we want our percentage, we would probably just leave that as 0.875. And actually, if we change that into a percentage, it would be 87.5%. And like I said, if you needed to, just go back and say 7 divided by 8 on my calculator is 0.875, and then move the decimal over 2 places to 87.5%. Then we need the 0a. Now that's already set up for us. Our a value is 15, so this will be 0a for the y-intercept, and that's going to be 0.15. So that's the first 3. I'll go ahead and clear this off and give you a chance to try number 4. Number 4 says, describe how the graph of each function is related to the graph of its parent function. So what I want to do is identify the parent function, and that's going to be y equals a times b to the x. So it says, describe how the graph of that function is related to that parent function. Well, the only thing that I have not explained yet is going to be the 2. So I would say that I need to shift or translate 2 units up, because this is definitely a k value. When we look at y equals a times b to the x minus h power plus k. Then it says to graph it. And what you need to remember is your table is just of the parent function. Y equals -3 to the x. And we could certainly put in some positives and some negatives, but what we want to think about is what we know it's already going to look like and put proper numbers into that. So the 3 to the x would normally give us a growth curve, but there's a negative, which means that's going to be reflected over the x-axis, which means it's going to go down. So I don't need a lot of negatives, and we'll maybe just stick with -1, 0, 1, and 2. So if I put a -1 in for x, that's going to be the reciprocal, so that's going to be 1/3, and we have a negative in front, so that'll be a -1/3. If we put 0 in, we're going to get a, and in this case, a would be a -1. Put a 1 in, we get -3. Put a 2 in, and we get -9. Again, follow the order of operations. You want to do the power first, and then multiply by the negative out front. So -1, -1/3, 0, -1, 1, -3, and 2, -9 gives us a really good idea of what the graph would look like. And then the second part of this is that we have to move it 2 units up. But when we do that, we are changing the asymptote. The asymptote was the x-axis, but now it's going to be the line y equals 2. And we go ahead and move all of the points that we had 2 units up and make that a solid curve, but making sure it does not look like it's going to cross the line y equals 2. It's going to get really close to it, but it's not going to cross it. So notice the directions. When it says then graph it, it says show the parent function graph, then shift it appropriately. So to make it a little easier on me when I'm grading these, you might want to go ahead and make this a dashed or a dotted line, so that I can see that you knew that that's what the initial shape was, but you didn't lose track of those points as you went through there. List the domain and range. Well, the domain for these is always all real numbers. But the range, that's determined by A, and whether or not it's positive or negative. So our range, we know our cutoff is 2, and then we have to look at it and say, all right, well, we're below that, so that's going to be less than 2. Never does it reach 2, because that is the asymptote. And that is the line y equals 2. You cannot just put 2 there. It needs to be y equals 2, because it is the equation for a line. Now we'll go through the same thing here for number 5. If you need to, go ahead and pause the video. Give yourself a chance to graph number 5. Problem number 5, we want to do the same thing. We want to identify the parent function. And the parent function in this one is going to be y equals 8 times 1/4 to the x. Again, we take y equals 8 times b to the x. And that's always going to be our parent function. And now we need to explain how this one is transformed, and that would be by shifting this down 2. And you certainly could put translate down 2 units. Doesn't make any difference. All right, now the rest of the instructions that we had involved graphing this to figure out what's going to go on with it. So we're going to graph y equals 8 times 1/4 to the x. And with this one, we see that we have a 1/4, and 1/4 is going to show us decay. We do have an 8, so that's probably going to make it go down pretty steep. But I definitely want to see what's going on if this is a -2, a -1, a 0. I pretty much know what's going to happen over there at 1, but maybe just to get an idea of what's going on. So if I take 1/4 to the -2 power, what that means is I'm going to have to flip it and make it a 4 and then square it, which is a 16. So I'm going to have to take 16 times 8, which is 128. That's definitely not fitting on my graph here. And then I take 1/4 and flip that and get 4 for the -1 power and take that times 8, and that will give me 32. Now the ones that you get on the test are going to fit nicely. This one is just really steep. So if we put a 0 in there, now we're going to get 0a, and that will be 0.8. And if we put a 1 in there, we're going to get 1/4 to the first power, which is 1/4 times 8, which is 2. So 0.8 and 1/2 will fit. And again, I know what that's going to do. It's going to approach the x-axis but never quite get there. And I'm going to make those dots pretty doggone big so I can use those to show that transformed graph, the moved graph. Because what I have to do is shift this 2 units down. And when I do that, of course, we are moving the asymptote again. It is not at the x-axis anymore. It is the line y equals -2. So what we have to do is go back to our points and say, all right, I'm going to move that 2 units down. Very steep graph. It's going to look like so. So our domain is, again, all reals. We can put in whatever numbers we want for that. But our range, we have a cutoff of y at -2. Then we just have to think, is it above it or below that? And our graph is above that, so it's going to be y is greater than -2. And then we need to list our asymptote, which is the line y equals -2. Really important to have an equation there for a horizontal line. And that y equals -2 is going to do that for us. So we've got all of that done for problem 5. I will move this up and give you a chance to try problem 6. You can pause the video and give that one a try. Again, with problem 6, we have the same directions that we had with all of the others. So what we want to do is recognize that our parent function is just y equals 3 to the x this time. We have an h and a k value on this one. So our parent function is y equals 3 to the x. Because it's x minus h, this is actually going to shift 2 units left. That doesn't look like the word units there. All right, and then we need to shift it 4 units down. So this one, a little bit more work as far as the counting goes, but it's just counting, so it's no big deal. We've got y equals 3 to the x, and that's going to be growth, so I know it's going to look like this. I don't need a lot of negatives. I'll maybe put -1, 0, 1, and 2 in here. Because it's a test, you know, even though we know what it's going to do over on the negatives, we should at least put 1 point there. 3 to the -1 is the reciprocal of 3, which is 1/3. 0 is going to give me 0a, which in this case happens to be a 1 since we don't see it there. 1, 3, and 2, 9, and this gives us a really good representation of this graph. So -1, 1/3, 0, 1, 1, 3, and 2, 9. And I will make those dots nice and big. And then I'll just put in some dots in between to show that I know what I'm doing. Then we have to move this. And a left and right shift is not going to hurt our asymptote at all, but you know, we've got a shift of 4 units down here, and so that's going to give us a new asymptote at y equals -4, and that will of course affect the range. And then what we need to do is go ahead and count and move our points. Oops, got carried away with that little dot there. We need to move those 2 to the left and 4 down. There's our new graph, and again, we absolutely want to make sure it does not look like it's crossing the asymptote y equals -4. Our domain, again, for all of these is all reals. Our range, well, our asymptote was at -4, and this graph happens to be above that, so it'll be y is greater than -4. And then what we were supposed to do was label that asymptote, which was y equals -4. Again, notice this is always y equals k for this asymptote. So there are some things that we can always count on with these graphs. All right, I will erase this and scoot this up, and then you'll have the chance to pause. Oops, sorry, that was kind of loud. There we go. So if you want to pause the video and try each one of these, now would be a good time. These say write an exponential function to model the situation and then solve it. Number 7 says you purchase a new car for $33,000. Your car depreciates at a rate of 14% per year. What's the value of your car after 10 years? Well, depreciation tells me I have to use the decay model. And the initial amount was $33,000. It is losing 14% per year. So if I change that to a decimal, that's going to be 0.14. And we want to know the value after 10 years. Now we might want to simplify this a little bit before we punch it in. And think, okay, if I had $1 and I subtracted 14 cents, how much would I have? 86 cents. And that'll just make it a little bit easier to punch it in. So now we'll have 33,000. And actually, we should probably do the order of operations as we go through this. So 0.86 to the 10th power. And then we need that times 33,000. And that gives us $7,302.95. So that $33,000 vehicle depreciating at a rate of 14% per year after 10 years would be worth $7,302.95. Number 8, the population of Mathtown is 72,000. The population is increasing by 22% each year. That was the information that I wanted to know because that lets me know I can use my simple interest formula. And they want to know what the population will be in 15 years. So we're starting with 72,000 people, and 22% is a decimal is 0.22. And we have 15 for the years. So it'll be 72,000 times 1.22 to the 15th. And this one we want to make sure that we can round this to the nearest person. So 1.22 to the 15th power, and then take that times 72,000. And we get 1,421,444.6. Well, you can't have 0.6 of a person, so we're going to have to round that up to 1,421,445 people. Number 9, a parent increases a child's allowance by 10% each year. If the allowance is $5 now, when will it reach $12? Now this was yearly, so we can use y equals a times 1 plus r to the t. And let's see what we have here. It says the allowance is $5 right now, and they are increasing by 10%, so 1 plus 0.10 to the t. And we want to know when that's going to be $12. So we can simplify a little bit here on the right hand side and say 1 plus 0.10 is 1.1 to the t. But now this isn't something that we can solve by hand yet. This is something where we need to use the graphing calculator, and it doesn't matter which one you make y sub 1 and which one you make y sub 2. But let me go ahead and talk you through your window. So get those two punched in first. Give you a second to do that. And again, it doesn't matter that x is our variable instead of t. The graphing calculator doesn't care. So let's go to our window. And what we want to know is when it's going to reach $12. So our x's are time. I think I'm going to make that 0 to maybe 15 years. Let's do that. 0 for x min and 15 for x max. And then we know that we're looking for $12, so y min could be 0, and maybe we make y max 20. That way we'll be able to see our $12. And almost right away the calculator has that graphed for you, and you hit second trace, number 5, and hit enter 3 times. And x, it says, is approximately 9.1854694 for that $12. Now, you're a parent, you're not a bank. If this is a bank, we definitely round up to 10 for the number of years. But because it's a parent, it's probably going to be more along the lines of 9.2 years. You know, parents are going to be a little bit easier on you than the bank will be. So about 9.2 years. If you're still receiving an allowance, then you'll be getting your $12. Now let me get these out of here and scroll up a little bit. All right, there it goes. And if you need to, because there's more space now so you can see 10 and 11 clearly, you can pause the video and try those. Number 10 says your grandparents invest $82,000 when you are born for your college fund. The account pays 1.5% interest compounded monthly. That means I'm going to have to use the tougher formula here. How much will you have when you graduate from high school 18 years later? So the formula for this one is the more complicated formula because we need n to say the number of times per year that this will be compounded. So that amount is going to be $82,000 times 1 plus, well, 1.5% is 0.015 divided by 12 because this is going to happen each month. And remember that 12 also goes up here for the power. And then 18 years later, that goes in for t. So one of the things that I probably would do right off the bat is say, what is 12 times 18, just to save myself a little bit of punching in later, and realize that this is going to be 216. So I'm really looking for 82,000 times 1 plus 0.015 divided by 12 to the 216th power. So again, I would use the order of operations here and take 0.015 and divide that by 12. Then I would add 1, and I would take that to the 216th power, and then times 82,000. And that gives us $107,398.97. Very nice of your grandparents to do that. $107,398.97. Number 11 says you put $4,000 into an account earning 2.5% interest, but this is compounded continuously. So that's our stinky green shampoo formula. Hey Bert, find the amount in the account at the end of 10 years. So we have $4,000 times E, which remember is a number, and our interest rate of 0.025, because it's 2.5%, we move that decimal place over 2 places, and that is for 10 years. So with this one, we would punch in 4,000 times, and then use second e to the x, and you'll see parentheses already popping up for the power here, or on the newer models it'll just pop up as a power, and we need 0.025 times 10. And you certainly could have done that math beforehand too if you wanted to. Multiplying by 10 is going to move the decimal place over one position, and that means you could substitute 0.25 for this instead of punching in all of that. Either way, you'll get the same answer. And that answer is going to be $5,136.10 because we get 0.101. And that means we would round that to the 10 cents. That is it. That's the practice test of 7.1 and 7.2.